A reference angle is the acute angle formed between the terminal side of a given angle and the x-axis on a coordinate plane. It's always positive and less than 90 degrees. I mean, yeah, it's less than 90 degrees because, you kind of get that from the acute angle. Copy this definition from Google because I'm kind of lazy. Let's get started. Now, let's say if you create an angle right over here. So let's say that we have an angle. Now, when I'm creating this angle, I'm going to use the x-axis as the base of my angle, and I'm going to draw a ray to create the angle. So notice how when I drew this ray right over here, it creates an angle with the x-axis. Let's call this angle theta. So I've created this angle with the ray, and it turns out that this ray right over here that I used to create the angle, that's called the terminal side of the angle. So in the definition of a reference angle, this terminal side right over here just represents, this ray that you create to, create this angle, this ray you've drawn to create this angle. Now, right over here, this is the first quadrant. So whenever you have like a graph, right, you have different quadrants or sections. This is quadrant number 1. This is quadrant number 2. This is quadrant number 3. And then this right over here is quadrant number 4. All right, so it's 1, 2, 3, 4. I don't know why I wrote it with Roman numerals. All right, so this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. The way you remember this is it always goes counterclockwise. Now in quadrant 1, the reference angle, is always going to be itself. So for example, if I have a graph right over here, I create an angle with my x-axis, right? And it creates this angle right over here. Let's just say the angle is 45 degrees. Well, the reference angle would be 45 degrees, right? Because it's this acute angle that's formed from this terminal side and the x-axis, right? It's this acute angle. 45 degrees is an acute angle because it's less than 90 degrees. Now, let's say that instead of creating a 45-degree angle, let's say that I create a 135-degree angle. What's the reference angle in this case? Well, in the definition, we said that the reference angle is positive and always less than 90 degrees. So obviously, 135 can't be my reference angle. So what do I do now? Well, the way I like to think about it is, look, this ray right over here creates another angle on the x-axis. So it creates an angle on this other side. And this right over here, this angle right over here represents the reference angle. So when you create an angle in the second quadrant, like so, the reference angle is always going to be using the other side. It's using the other side of the x-axis. And in this case, you can find out what the reference angle is by taking 180 and subtracting 135 from it. All right, so you take 180 and you subtract whatever angle that you have in the second quadrant. The reason why you do this is because, think about it, right? Think about this. A straight line has 135 degrees, and you're trying to find this angle right over here. So if I subtract this whole part by this part right over here, so if I subtract this whole part, so if I take this whole part, and I subtract it by 135, which represents this part, well, the only remaining angle that I'll have is my reference angle on this side. 180 minus 135 is 45. And that is the reference angle. Say it's, 240 degrees. What will my reference angle be? Well, the reference angle, once again, right, is this acute angle created by the x-axis and the terminal side of the angle. So right over here, if I make this part of the x-axis, right, if I get this part of the x-axis and I get this part of the terminal side, right, this is the terminal side of the angle, well, look what happens. I get an acute angle, like so. All right, so whenever you're creating a reference angle in the third quadrant, it's always going to be this tiny angle right over here. It's going to be this tiny angle. How do you find out what this is? What you're going to do is you're going to take your angle and you're going to subtract it by 180. So this angle right over here would be 60, and that's your answer. And the reason why you do this, well, think about it like this, right? This whole part right over here, right? This whole part right over here is 240. Now I'm only trying to find this tiny part. So what I'm going to do is I'm going to take this whole part and I'm going to subtract it by this other part, which is 180, right? I'm going to take this whole angle right over here, and I am going to subtract 180 degrees, like so. So that now I subtract this part out, and I'm only left with this tiny angle. So if the reference angle, if the main angle that we create was 250 degrees, well, my reference angle, all I have to do is I take 250, I subtract 180 degrees, and then I get 70. So my reference angle would be 70. Finally, reference angle in the fourth quadrant. Using a lot of colors in this video. Let's say if I have a 330 degree angle, what's my reference angle? Remember, reference angle is this acute angle formed by the terminal side of the angle, and it's formed from the x-axis. Right? Whenever you're doing reference angle problems, sometimes you can just think about this logically. All right, this is my terminal side right over here. If I use this side of the x-axis to create my reference angle, well, that's obviously bigger than 90 degrees, right? So I can't use this side. So that means that I have to use this side of the x-axis and for this reference angle to be created, right? If I use the other side, this angle right over here would be much greater than 90 degrees. So it can't be the reference angle. The reference angle would have to be this angle right over here. How do you solve this? How would you solve this? What you're going to do, if your angle is in the fourth quadrant, you do 360, you take 360, and you subtract that angle. So the reference angle right over here would be 30 degrees. Now, why would this work? Think about it. All right, so one rotation like so, right? If I sort of create a circle, right? So this represents a 360 degree angle. So if I have an angle, right, and I go around, this angle goes around one time, this angle right over here would be 360 degrees, right? If I have an angle like this, right, this is, let's say, a 45 degree angle, right? If I just move this terminal side around all the way around the unit circle one time, right? So I move this angle all around the unit circle one time. This right over here represents 360 degrees, right? This whole thing is 360 degrees. Now, you know that I'm trying to find out this angle right over here. So what I'm going to do is I'm going to take this whole part and I'm going to subtract it from the angle that I've created, right? So what I'm going to do is I'm going to take this whole part right over here and take this whole part right over here. And what I'm going to do is I'm going to subtract this angle right over here that I've created. I'm going to subtract this angle right over here I've created in the red part. So that means that the only part that will be remaining is this tiny part right over here, right? If I subtract out this whole part right over here by the whole thing, right, by 360. So I subtract 330 from 360. Well, guess what? I'm just going to be left with this tiny part, which represents the reference angle. So just for a quick recap, if your angle is in quadrant 1, the reference angle is equal to the angle that you created. If your angle's in quadrant 2, well, what you're going to do is you're going to take 180 and you're going to subtract it from the angle created. And that's going to give you your reference angle. Oh, wrote a little bit too big here, but it's fine. If you're in quadrant 3, what you're going to do is you're going to take your angle and you're going to subtract 180 from this to get the reference angle. Finally, if you're in quadrant 4, what you do is you take 360 and you subtract it by the angle that you created. And that's going to give you your reference angle. Let's just do a couple of random problems and let's begin. And feel free to, pause the video at that point and then just kind of review the things a little bit. So let's say if I have a 56 degree angle. Let's say if I have a 56 degree angle, what is the reference angle? Well, a 56-degree angle would be in the first quadrant. So this would be a 56-degree angle right over here. And the reference angle in the first quadrant is just the angle itself. So the reference angle would actually be equal to 56, right? Because this right over here represents the terminal side, this represents the x-axis, and this creates a positive angle that's below 90 degrees. Let's say if I have a 120-degree angle. What's the reference angle in this case? Well, look, I know the angle 120 is going to be in the second quadrant. I know it's going to be right over here. All right, so when I create this angle, I know it's going to be right over here. And the reason for this is because, think about it, right? This right over here represents 90 degrees. So this angle that I've drawn represents 90 degrees. And obviously 120 is bigger than 90 degrees. So it's going to be in the second quadrant. It's not going to be in the third quadrant because in order for an angle to be in the third quadrant, well, you have to be greater than 180 degrees, right? If you want something to be in the third quadrant, that angle has to be greater than 180 degrees. So, 120 is in between 180 and it's greater than 90. So therefore, it has to be in the second quadrant. Now, well, we created a 120-degree angle, right? So what's our reference angle going to be? Well, we said how the reference angle is going to be this angle right over here. And our reference angle uses this part of the x-axis, right? Because if we use the other part of the x-axis to create this reference angle, like imagine if the reference angle was like this would be an obtuse angle, and it'll obviously not work. So I create the acute angle here, and well, what I do is I take 180, subtract it by 120, and I get my reference angle is 60. Let's say that I create a 259-degree angle. What's my reference angle? A 259-degree angle is right over here. So, like so. 259-degree angle looks something like this. Actually, if I'm being a little more realistic, it's going to look like this. And the reason why I know that it's in the third quadrant is because, well, 259, that's greater than 180 degrees, which means it must be past the second quadrant, right? If you have an angle 180 degrees, it's going to land in between the second and the third quadrant, right? And obviously 259 is greater than 180. So that means that the angle is greater than 180, which means it has to land right here. I know that my angle right over here is less than 270. 270 represents this angle right over here. This angle right over here. But because 259 is less than 270, it's going to land here. What I do is I take 180. Now what I do is I take this angle right over here, and all I have to do is subtract it by 180. So this is actually equal to, that's 79, I believe. Finally, if I, let's say, have a 340-degree angle, like so, 340-degree angle lands in the fourth quadrant. It's less than 360, but it's greater than 270, right? This is 270, this is 360, right? One loop. This angle right over here is 270, and it's in between these two lines, right? It's in between these two angles, so that means that it must be here. Now, what I do is I take this full 360-degree angle, and I subtract this tiny part so that I get our reference angle, which is this part right over here. Right, my reference angle. My reference angle is this part right over here, right, by this x-axis and the terminal side of the angle. So 360 minus 340, that's going to give us 20 degrees. Now, tricky question. Let's say I have a 370-degree angle. Where would this land? Well, think about it, right? Let's say I have an angle theta. And let's say I go 360 degrees. Let's say I go 360 degrees around here. So this other angle right over here is equal to theta plus 360. So I have this angle right over here, which I have as theta, and this other angle right over here that's gone around the circle one time and looped back to the same place, that angle is theta plus 360 degrees. Notice how these two angles are literally the exact same angle, right? They land at the same spot. They're the exact same, they have like the exact same terminal side, all right? If I create a 30-degree angle and I go one loop around the unit circle and then I go back to the same place I started. So this big angle right over here would be 30 plus 360 degrees, which would be 390 degrees. And it's plus 360 because a circle, right, has 360 degrees, right? So you can imagine this as like one loop around a circle, right? So this angle goes one loop around the circle, and it's just going to be that angle plus 360 degrees. And when you look at that, when you create an angle and you have the same angle added to 360 degrees, the terminal side of your angle is the exact same. It's the exact same ray. The ray for 30 degrees is the exact same ray or terminal side for 390 degrees. All right. So using this logic, if I have a 370-degree angle, this is going to have the same terminal side as a 10-degree angle. And the reason why is because 10 plus 360 gives you 370, right? And an angle plus 360 gives you the same thing as that original angle. It gives you the same ray as that original angle that you've started with. And so using this information, if I have a 10-degree angle, it's going to land in the first quadrant, meaning that the reference angle is the angle itself. So the reference angle is going to be 10 degrees.